Everybody, welcome. Today we're going to be introducing the topic of annuities. Okay, so here we got a situation where we're into week 6, and so far all we've been doing is talking about time valuation, or how does money change value over time. In the first instance, when we talk about simple interest, it was generally for loans that were less than 1 year, and that we apply just a straight, simple, non-combined interest rate on that. That was the first thing. Then we moved to a single payment that was made probably over a course of years, and we said, how much is the value of that worth at some point in time? So we had what was called compounded, or interest upon interest type of payment. And now we're moving into something called annuities. And annuities just means a stream of money. And it's more realistic, like a bank loan, for example. If you were to go buy a car, you're paying it off in payments, let's say $500 a month for 60 months. So over the course of 60 months, every single month you pay $500. And once you're at the end of the 60 months, the loan is paid off. That's really an annuity, okay? It is a stream of payments, a flowing stream. What we're looking at here is covered in chapter 10 of the textbook, and 11. 11 again fleshes it out. We're focused on the even chapter. And so it is really this kind of a stream, okay? It's very common in insurance and retirement and banking. And, you'll do a lot of this. Again, it's all done by computer now, so we don't physically have to do these complicated calculations they're not complicated, but these cumbersome calculations, I'll call them cumbersome. We don't necessarily need to do these cumbersome calculations anymore, but we certainly have to have an appreciation where those numbers come from. So the point of this is to go through the mathematical mechanics behind these calculations that computers do. Annuities are just so common too that this is something that has absolute real world benefit to you, and is something that every business should be aware of how this works. Annuities differ from regular compound interest because the money is continuously paid. So the loan is paid off in dribbles as opposed to one single payment at the end. What we're going to do here is we're looking at this compound interest method to calculate an annuity. And there are different types of annuities. There's simple annuities and there's general annuities, and we'll look at those. We're also going to look in the next section, but again, still within annuities. We're doing 2 sections on this. We're doing week 6 and 7, we're looking at simple and general annuities. And then in week 8, we're going to be looking at annuities that are paid at the beginning of the month. In terms of annuities, what we got is some basic terminology. So the basic. First, we have payment interval, which is the time between the payments. Once a month, once a year, once a week, every 2 weeks. So it really is the distance between payments that are made. Every problem that we deal with will have some valuation of the payment interval in it. The next thing that we have to concern ourselves is with what's called the term of the annuity. Most annuities have a set term. For example, that bank loan for the car that I talked about, 60 months. The frequency is the time between the intervals. Typically, it's an annual, semi-annual, and so on. The payment, which is the amount of the payment, and it's short. The terminology that we use for that, the short, is PMT. And the payment could be made at the end of the month or the beginning of the month. I would turn that wording around that I have there. We're looking at most of the time when annuities are paid, they're paid at the end of the month. Most of the time. In fact, the ones we're looking at here are always at the end of the month. There are a type that are made at the beginning of the month, and they're called annuities due. And we'll look at those later on. And N is simply the number of payments in the annuity. So you can see by this little, again, we're using this timeline thing here constantly. The timeline is, okay, here's a payment, a payment, a payment, a payment. So basically, period 1, 2, 3, and right on through. As I said, annuities can be classified in 2 basic ways, and there's criteria. When the annuity payment is made, at the beginning or the end of the month, and how often the compounding frequency is. These are a couple things that we need to consider ourselves with in every single problem. And then we got this thing called the compounding frequency. The compounding frequencies, as we've seen with compound interest, compounding frequency is sometimes given to us in variations. You know, it's compound, the interest is compounded daily, weekly, monthly, semi-annually, quarterly, these sorts of things. First and foremost, we're going to be looking at our number one type of annuity, which is called the ordinary simple annuity. The ordinary simple annuity has a couple of characteristics. First of all, the payment is made at the end of the month, as most annuities are. The payment is made at the end of the interval. And the trick is you have to ask yourself, in order to determine whether something's an ordinary simple annuity, is the compounding frequency the same as the interval? What that means in English, if your payment is monthly, is the interest being compounded monthly? If the payment is monthly and the interest is compounded monthly, then it's called an ordinary simple annuity. If, for example, the interval is yearly and the interest is compounded yearly, it's an ordinary simple annuity. So both of those things had to be equal. That's one of the little checks we need to do in the problem when we get the problem, is to say, is that exactly the same as the interest compounding frequency? If it is, it's an ordinary simple annuity. The first section, in this section that we're dealing right here today, what we're looking at is we're looking only at number one. We're looking at the ordinary simple annuity. This is what we're going to look at first. Okay, so this is what we're looking at today. Here's a little timeline. So what we're doing is we're taking $5,000. We're going to set it aside for 5 years, or we're going to put it in the bank for 5 years. And at the end, we want to know how much it's worth. So let's say if we took $5,000 and we put it in, well, it'd be 5,000, 1 plus I, so 1.10, 10% interest. And it's going to sit there for 1, 2, 3, 4 periods, hence the 4. It will be worth, because we're putting in it at the end of the period, keep in mind, right? So it's only sitting there after year 1. So it's going to sit for 1, 2, 3, 4 years. So it'll be $7,321. It'll be worth $7,321 at the end of the period. That's the same math that we were doing last week. Same thing here. If we took this green $5,000 and we set it aside for 3 years, 1, 2, 3, it would be worth $6,655. And if we took the year 3 and set it aside for 2 years, earning 10% interest, it would be worth $6,050. And the 5,000 here, we set it aside for 1 year, it would be worth $5,500. And we set 5,000 aside on the day that we took it out of the bank. You know, we put it in and took it out the same day, seeing we were valuing it at this date, it would be worth $5,000. If we add up all of these individual payments, it would come to $30,526. In other words, that $25,000 in raw money would have grown to $30,526. Now, this is a cumbersome calculation. We got to do 5 individual calculations in order to come up with this, right? So imagine that it was 25 years or 30 years. It would become an even more cumbersome calculation. Now you say, well, we got spreadsheets that can do it fairly easily. True enough. But what if we had a formula that could allow us to calculate this sort of thing and get this answer without having to go through all this process? Well, here it is right here. So this is the new formula that we need to be aware of today. And this is the future value of a stream of money for a period of time, assuming that it is what we call a simple annuity, meaning that the payment period every year and the compounding period, and in this case, it's every year, are the same. So the interest, the compounding is the same as the payment. So this is what's called a simple annuity. And here's the formula for calculating a simple annuity. If you look at what those numbers mean, well, future value, we've seen that. We know FE is future value. Payment is the amount of the payment. And I is the interest rate per period. And, you know, same as what we've done before. And N is the number of periods for which the annuity will last. So that's something you need to be aware of there. It's how many periods will the annuity last? So here's an example of it applied, and this comes right out of your book. So Heinz has been contributing $300 at the end of each month for the past 15 months to a savings plan that earns 6% compounded monthly. What amount will she have at the end? Okay, so we gotta look at that problem, and the first thing we need to do when we look at the problem is to ask ourselves, is this an ordinary simple annuity? Now, all these are ordinary simple annuities, so it's you say, well, of course, this is a simple annuity. This is what we're talking about. But here's how you decide that: $300 at the end of each month, and the 6% is compounded monthly. So the payment period, or the payment is made monthly, and the compounding is made monthly. The compounding and the payment are the same. It's a simple annuity. It also uses the word at the end. $300 at the end. And we ask yourself, is this an annuity or an annuity due? Well, it's an annuity because normally the payment is made at the end. That's what's called a plain Jane, straightforward annuity. So this is an annuity. So it's what we call an ordinary simple annuity. It's simple in the sense that the compounding and the payment are the same, or the payment period is the same, I should say. And it is certainly an annuity and not an annuity due because the payment is made at the end of the period. So what we do is we take those bits of information and we take our formula here. Okay? We take our formula and let's put the information into the formula. Well, first of all, the payment is stated at $300. The second thing that we have is the interest rate. We're looking for the interest rate. Now, just like before, the interest rate is 6% compounded monthly. So what we need to do is take the 6% and divide it by 12, and that will give us 0.5% per month, or the compounded interest rate. And that comes to 0.005. That's where that comes from. And then we're going to ask ourselves, well, how many compounds are in this type of problem? Well, let's see. At the end of each month for the past 15 months, okay? So that's 15 months. And then we say, what amount will we have 1 year from now? So we got 15 months plus 1 year from now, which is 12 months. So 15 plus 12, that's where that n comes from here, of 27, 15 plus 12, the minus 1, over the interest. We throw all that through our calculator, or Google, as I prefer to do, because Google allows me to see it all put up there, and we will get $8,649.11. So effectively, this is the value of, all that's saying is that after 15 plus 12 months, 27 months of paying $300 a month and earning 6% compounded monthly, it will value up to $8,649.11. Let's take a look at this straightforward one, number one here. This problem demonstrates the dependence of an annuity's future value on the size of the periodic payment. Suppose a fixed amount will be invested at the end of each year, and that the invested funds will earn 4% compounded annually. What will the future value of the investment after 25 years if the periodic investment is? Okay. So let's just kind of pick this apart. Let's assume that we don't know that this is an ordinary simple annuity. How can we determine if it's an ordinary simple annuity? Well, the criteria is that we have to ask ourselves, is the payment interval and the compounding period the same in terms of the actual length? Well, let's see. The payments are made at every year, and the compounding is made every year. Yeah, so we got annual compounding and payments at the end of the year. So that's once a year, once a year. Yeah, it's an ordinary simple annuity.
So we've got the period is 25 years. We've got 4% interest, and it's compounded annually. So we don't have to do anything with the 4% amount. And so in the first case of A, the payment is 1,000. Okay, so what we'll do is now we're going to plug this into this formula. So we're looking for, in this case, the future value, because it says, well, what is the future value? But also we know we got to add it up to something, so it's going to come up the same amount. So we'll use the formula here. FB equals EMT 1 plus I to the n minus 1 over I. Now, you guys can use your calculators for this too, but I'm just going to go through the example with it, okay? Now, everybody's calculator is slightly different, so you had to figure out how to use your calculator in order to do this. So let's plug this in. This is the payment is 1,000. 1 plus I, and I in this case is 4%, 0.04. And the n is the number of periods. It's annually paid, so 25 periods. Minus 1 divided by 0.04, which is the I. We run the math on that in our calculator, and I'll just see if I can squeeze it to the end of the sheet here. And it comes to, and I don't think it can, $41,645.91. So essentially, if we put $1,000 away every year for 25 years, there's $25,000 worth of payments. But with interest, it will have grown to $41,645.91.
The second one is $2,000 per year. But basically, this is how you do. You assume $2,000 a year. So this is B. The future value formula, you plug the information into the formula. And again, it's 4% annually, so that's 0.04, and it's 25 years, so it's 25 payments or 25 compounds, whatever we want to do. That's 25. You run the numbers on that, and that will come to $83,291.81. What that means, if you put $2,000 away at the end of the year for 25 years, earning 4%, it would accumulate after 25 years to $83,291. So that's as far as we're going to go today. I thank you ever so much for taking the time to join me.